Okay, we'll finish section 2.3. Now we left off here, and I've kind of started the problem because I didn't want you to just watch me draw it. Okay, 110 college freshmen. We've got all this information. We have 3 sets where the universal set is the college freshman. Then the other 3 sets are physics, biology, and math. So I've intersected all 3 of them like we normally do. And now I'm going to start filling this in with the information. Then I'm going to ask some questions. Now, when I do this, I start here and work up, because then I can use logic to finish everything out. So 5 took all 3. Well, that's 5 in here. Now, when I say 6 took physics and biology, that's the intersection of physics and bio. Well, here's the intersection of physics and bio. There's 6 in that intersection, but I've already listed 5. So I just add the other 1 there. Now there's 6 in the intersection. Same thing, 8 took bio and math. That's the intersection of bio and math. Notice there's already 5 in that intersection, which is here. So all I have to do is add 3 here. 10 took physics and math. Again, that's the intersection. There's already 5 in there. So I do the 5 there. Now I can fill in the other 3 spots. There's actually 4 because I have some that may not be in any of them. 48 took math. Well, I already have 5, 10, 13. So there's 35 out here that only took math. 45 took bio. I have 6. I have 9. 45 subtract the 9. 36 only in biology. And then 25 took physics. There's 11 there already. So only 14 took only physics. Now, let's see if I can add these up in my head. 14, 50, 60, 90, and 9. So there's 99 in all of here. So outside here, there's 11 who didn't take any of them. So here's some questions that I may ask you. What's the cardinality of the complement of P intersect B? Well, the intersection of P and B, we can look up there, we have 6. So this must be 110 subtract 6 is 104. That's everything that's not in the intersection. That's the complement. Let's try one more. What's the cardinality? Let's do P intersect B union with math. Let's see, P intersect B is here. I want to union that with math, which is all of these. So be careful, because as you can see, it'd be better if I did another color here. That 5 got counted twice. So we just want to count each thing once. So this would be, there's 6 in the intersection, that's this, plus 43. So this is 49. Another way to count it would be count all of the ones in M, which is 48, and then add the other one that's in that intersection. Okay, the last topic that I want to talk about is, well, I'll let you answer some of these. By the way, if you want to look at this last one, since I have space, how many did not take any of the three? That's the cardinality of P union B union math, but didn't take them. That's a complement of the union of all three. That's the stuff that says nobody took any of the three. That's the 11. Okay, Cartesian products. I'm doing this because later on we can use this to define multiplication. A big development in math, once Cantor did sets, was linking arithmetic and such to set theory. So here's two sets. If we want to know the possible ways that you could dress, we know it's 3 times 2. There's 6 possible ways because of the fundamental counting principle. Now, we're going to do the Cartesian product. I'm going to make ordered pairs. All of the ordered pairs I can make between these two. For example, one ordered pair would be blue, comma, blue. Notice I'm putting the P elements first because these are ordered pairs. So I'm going to make another one. It would be green, comma, blue as well. And I could do white, blue, and then do blue, red, green, red, white, red, and have my 6. So if you recall ordered pairs from algebra, you use them a lot to graph on what was called the Cartesian plane, where you did X and Y. So if you wanted to graph 5, 2, you went out to 5 and up to 2, and there's a point on your plane for the ordered pair 5, 2. X always came first. So here we have some set notation. A cross B. We're doing the Cartesian product such that it's the set of all ordered pairs such that X is an element of A and Y is an element of B. So the A elements are going to come first and the B elements will come second in our ordered pair. Oh, this is very busy. I should have deleted some of this. Let's just look at the first one. So notice there's the brackets because we're building a set of ordered pairs. So the element of A, which is little a, goes first, then they paired it with 1. Then it did A and 2, A and 3, moved to B and 1. So it's always an element from A first, an element from B second. And notice that N of A is 3. N of B, the cardinality, is 3. So in our set, the cardinality of A cross B is 3 times 3 is 9. That's our definition of multiplication, basically. This is X element of A, Y element of the null set. Well, since there's nothing in the null set, when we take any set, cross it with the null set, we get the null set back because there are no ordered pairs we can make. So it will be empty, meaning there are no ordered pairs in it. And that's it.